welcome to the next video in this series. And in this video, we're going to talk about how we can measure heat. And heat is not the same as temperature. If we wanted to measure the temperature of something, we could take out a thermometer and we can stick it in or on that substance, and we can get a reading of the average kinetic energy of those molecules. When we are talking about heat, we cannot measure heat with a thermometer. Okay, heat is a transfer of energy from one substance to another. That's how we're going to measure this. And heat is measured in a unit called joules. Alright, hopefully sorry about the scribble, I didn't erase it from the last time. Alright, so let's say we want to measure heat. We are going to measure that heat in a unit called joules, and it's spelled a little bit differently than you would expect it to be spelled. Alright, the amount of heat lost or gained in a reaction can be calculated using the following equation, and we find this equation on table T. Let me show you exactly where you're going to find it. There, erase my thing. We got reference table T, and right down here is a section that says heat, and I'm looking at this formula right here. Q, which is heat, and you might want to write in that it is measured in joules just so you have it. M is the mass, it tells you right here, and it's measured in grams. C is specific heat capacity. Well, we have to revisit that because we have to look on another chart to get that, and I'll explain what that is in a minute. And finally we have delta T, or triangle T, and that triangle T means change in temperature. Okay, so let's go back to our notes page and erase that. And I wrote down here for you what everything is. Q is joules, which is heat. M is mass in grams. C is specific heat. And delta T is change in temperature. Alright, specific heat. Specific heat is specific for every substance. We are going to be interested in specific heat of water 99.9% of the time, unless they're asking you to calculate specific heat. But they're generally going to be asking you to calculate the temperature change or the heat or the mass of water. So when they're talking about water, lucky us, they give us on the reference table, on table A, I think it's A, maybe it's B, I think it's A. Let's go all the way up, come on, come on, you can do it. There it is, it's table B. On table B, they give us the specific heat capacity of water. And the specific heat capacity of water tells us that we need 4.18 joules, that's what that J stands for, to raise 1 gram of water 1 Kelvin. Sometimes it will say 4.18 joules per gram degree Celsius. Now Kelvin and degrees Celsius are interchangeable in this case, because if I raise something 1 degree Celsius, I'm really raising it 1 Kelvin. They are a 1-to-1 ratio. Okay, so it's telling me I need 4.18 joules every time I want to raise 1 gram of water 1 degree Celsius, or 1 gram of water 1 Kelvin. Okay, let's translate that to what we actually are going to be doing. Let's assume that we have a solid. Let's see, a solid. Oh, I can write right on here. And the solid, if you recall from the heating and cooling curves chart, was located right here. This is solid. From segment A to segment AB, right? From A to B is a solid. And then over here we had solid to liquid, and then we had liquid and liquid to gas and gas. Okay? This is the segment we're going to look at. I can even break out my handy dandy highlighter. Let's see, we'll do it in green. Let's just look at this segment. So I'm going to take a solid, and let's assume that solid has a temperature. If we're assuming this is the heating curve for water. This is 0. Let's assume this solid has a temperature of minus 20 degrees Celsius. So it's somewhere around here. This is where we're looking at. Okay? And then we're going to take that solid and we're going to raise that solid. Oops, that's the same size. It's the same size as this. Doesn't look like it. Let's see, can I erase that? Let's see. Okay, that's a little bit closer. And we're going to raise that to 0 degrees Celsius. So we're going from here to here. From negative 20, this is negative 20, to 0. It takes time to do that because I'm adding heat, right? I'm adding joules. Well, how many joules am I going to need to add? That's what I'm trying to calculate right now. From negative 20 to 0. And we have this solid, and this solid weighs, I don't know, let's make it 5 grams. It's the same 5 grams over here. So that 5 grams of solid ice went from negative 20 degrees to 0 degrees. And we want to find out how much heat it took. So let's write our formula down. Q equals mc delta T. And we know that Q is the amount of joules, or the amount of heat that we're going to need. The M stands for mass in grams, so the mass in grams is this 5 grams of substance. The specific heat was the amount of heat, or 4.18 joules, needed every time we want to raise 1 gram of water 1 degree Celsius. So we need to put that constant in, so we have that factored in, that we need 4.18 joules every time we want to raise 1 gram of water 1 degree Celsius. And we have to factor in what the delta T was. Now the delta T was the change in temperature. Well, it went from negative 20 to 0. Now from negative 20 degrees to 0. The change will always be a positive number. Okay? When we do change in temperature, we're counting from negative 20, then negative 19, negative 18, negative 17. The distance that it went from negative 20 to 0. That's a total, ooh, that came out better than I expected, of 20 degree change. So I'm going to put 20 degrees in here, 20 degrees Celsius. And when I do the simple math, I can figure out how, whoops, I got my calculator, 5 times 4.18 times 20, and I got 418, oh, I could have done that in my head, 418, and we need units. Okay, what is Q going to equal? Well, if you're following along with the units that I wrote in, these grams are going to cancel, because one's in the numerator, one's in the denominator. Celsius is going to cancel, because one's in the numerator, one's in the denominator. The only unit we have left is joules. And that's good news, because that's what we were trying to find. How much heat did it require? How much heat did it take to raise this 5 grams of ice from negative 20 degrees to 0 degrees? The only time we can use this formula with the delta T in it is when there is a change in temperature. And there's only a change in temperature when you have a single phase of the substance you're talking about. In other words, you only have solid, 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 or liquid, liquid, or gas, gas. There is no temperature change here. And so if there's no temperature change, let's say I said 0 degrees and 0 degrees, my change in temperature would be 0, and if I multiplied 0 times anything, I would get 0, and that's not true, because I'm constantly putting heat in. Remember, I was putting heat in every minute on a regular interval, whether it be 100 or 200 or 300 joules per minute. I need 418 joules to be added between here this spot right here, whatever that time is, and this spot, so that I can go from negative 20 degrees to 0 degrees. I hope this is making sense. Alright, let's try some problems. Keep in mind this all relates to this graph. I don't want you to forget that when we are dealing with this formula, we are only talking about these 3 segments of the graph, because that's where the temperature change is taking place. Okay, let me get my little pointer thing here, and let's scroll down to our first problem. Alright, your biggest obstacle when doing these problems is going to be figuring out what they are asking you to do. I've been trying to focus you on looking for the question word, and in this case the question word is how. Right after the question word is going to tell you what they're looking for. How many joules? Soon as I see the word joules, I know that they are talking about heat. Okay? So my mind races, and my mind says, hold on a second, I just gotta get my pen. My mind races, and all of a sudden I say, they're talking about heat. I need to be looking at this formula, or this section of table T. Right here. Now, since this video is only talking about Q equals MC delta T, and not these other 2 formulas, which we'll get to in the next video, this is the formula we are going to use. And you must write it down. I know that that's crazy, and some of you say, I can do this in my head, I don't need to write it down. Well, nobody knows what's going on in your head if you don't write things down. Okay, so now I got my beautiful formula written right there. Okay, I also suggest that when you do these problems, and you can get yourself a highlighter, or you can use a colored pencil, or whatever you want, and highlight the information they gave you. First of all, they're telling you heat is being absorbed. That means heat is going in. It is an endothermic reaction. We are putting heat in. And if it is endothermic, okay, heat is entering the substance that you are talking about. I just want to put that out there. I know that you probably know that already, but whatever. Okay, so we've got 150 grams of water. 150 grams is my mass. Mass equals 150 grams. I'll just write H2O here so that make everybody happy. Okay, that's my next piece of information that I have. Then I'm looking for C and delta T. Well, we're heating it from 50 degrees Celsius to 60 degrees Celsius. What's my change in temperature? My change in temperature is going to equal the distance between the 50 and the 60, which is 60 minus 50, which is 10 degrees Celsius. That's the change in my temperature. Now we have to find, let me find another pen here. We have to find C, which is the specific heat. Well, they're talking about water. And on table B, like we saw before, table B, the specific heat of water is 4.18 joules per gram degree Celsius. So I'm going to write that in, 4.18 joules per gram degree Celsius. Now, if I can take the time to write in all my units, you can take the time to write in all of yours. Alright, let's plug everything in. Q is what I'm looking for. How many joules? And joules is Q. That's heat. Equals mass, 150 grams. My C, I have it right here, 4.18 joules per gram degree Celsius. And my change in temperature is 10 degrees Celsius. 150 times 4.18 times 10. Q equals 6,270 joules. When you're done doing a problem, this is what you should have on your paper. Not a piece of information up here and a piece of information down here. It should look just like this, with your formula, with the givens, what they gave you in the equation or the problem, plugging them in, solving for your answer. You don't have to write this because it's on table B. I just wrote it for you so you can remember where to find the specific heat of water. Alright, let's go to the next problem. If I can find it. Aha! Now this question, let's get a green pen. It says, what? That's my question word. And right after my question word is what they're looking for. And they're looking for specific heat. So over here, I didn't even read the problem yet. Over here, I'm going to write C equals my question. I don't know what the specific heat is. They are obviously not talking about water, because if they wanted the specific heat of water, we could look on table B. Okay? Now, we want the specific heat of a substance if 90 grams. Now, this unit right here gives us a clue as to what that is. It is mass. Mass in grams. Okay? Whoops, I should have wrote the number. 90 grams. Okay? Of the substance cools from 50 to 28 degrees Celsius. Alright, so it's going from 50 degrees Celsius to 28 degrees Celsius. When it goes from 50 to 28, we have a change in temperature. What's that change in temperature? It's 22 degrees Celsius. Now, I don't even have a formula over here yet. I don't know anything yet. I'm just going through my problem and pulling out information from that problem. I think there's a little decimal there, but I don't think it's supposed to be. Maybe it's on my screen. I don't know. It's supposed to be 528 kilojoules of energy. Alright, so now Q equals, there's my units, kilojoules. What's a kilojoule? A kilojoule, well, kilo means 1,000. So there are 1,000 joules in 1 kilojoule. Well, oh, maybe there is supposed to be a, there is supposed to be a decimal there. Sorry about that. That's why there's a decimal there, because it was in kilojoules. Silly me. Okay, so 0.528 kilojoules. If I have 1,000 joules in every 1 kilojoule, how do I change kilojoules to joules? Well, I have to multiply by 1,000 to get to joules. And when I do that, I move my decimal 3 places to the right. So we get 528 joules. If you can't see that, let me just do it over here for you so you can see. 0.528 kilojoules is how many joules when 1 kilojoule is 1,000 joules. I set up a proportion where kilojoules are the same on the top and joules are the same on the bottom. Now I can simply just cross multiply. Okay, so joules will cancel because that joules becomes a numerator. Joules and joules will cancel. Kilojoules and kilojoules will cancel. And I'll end up with 528 joules, which is what I wrote here. 528 joules. Okay, let's get a eraser and erase this. Alright, so I have a bunch of given information here, and now that I have that information written as givens, I can go back and I can look at my reference table and I can say, oh, Q I have, M I have, C I'm looking for, specific heat, and delta T I have. So now I know what formula I'm using. Q equals MC delta T. I'm going to go back to my paper and I'm going to write that formula down so that I don't forget what it is. Q, that's what happens when you use a big eraser. Okay. Q equals MC delta T. Q equals 528 joules. I'm going to leave it as a J. My mass is 90 grams. My specific heat is what I'm looking for. I'm going to make that, I'll leave that as C. And then my change in temperature is 22 degrees Celsius. So, alright, now, remember the units for specific heat. Specific heat for water was 4.18 joules per gram degree Celsius. Well, we're not talking about water right now, so we don't care about this, 4.18. But just look at the units. Joules per gram degree Celsius. If I take this grams and I move it to the other side of the equation, this is algebra way back in the day, the way we used to do it. That grams would go to the bottom here. It would go to the denominator. And this degree Celsius would also go to the denominator. Look, joules per gram degree Celsius. Joules per gram degree Celsius. So what I did was I divided this side by grams and this side by degrees Celsius. I also divided this side by grams and degrees Celsius. So these right here canceled, and these guys canceled. The C is what I'm looking for. That's my specific heat. And on this side of the equation, I got joules per gram degree Celsius. Now we have to also divide both sides by 90 and divide both sides by 22. So when I move this 90 over to the other side, come here, you. I'm going to divide both sides by 90. That will cancel this 90 out. I'm going to divide both sides by 22 degrees Celsius. With the degrees Celsius already over there, so let's not put that in to confuse you. Alright, and we've got 22, and we've got 90. So basically what I have here is 528 joules divided by 90, 22 grams degrees Celsius. And that's going to equal my specific heat. So when I take 528 and I divide it by 90 and 22, I get C equals 0.27 joules per gram degree Celsius. That's my answer with the correct units. Now, if you don't get the units part, you know that you're looking for specific heat. Go to your reference tables, look at table B, on table B it gives you specific heat. Use the same units that they gave you. Okay? So if you don't get the units part, how I solved for units, you can always just look it up. Alright. Let's move on to the next problem. And the next problem, a little bit different, right? Let's see. Let's get this off that page so we're not confused. The temperature of a sample of water in the liquid phase, so it's only one phase, is raised 45 degrees Celsius by the addition of 2,000 joules. What is the mass of water? What is the mass of water? We're looking for mass. So M is what I'm looking for. They gave me the temperature of the sample of water is raised by 45 degrees. They didn't tell me it started at this temperature and went to that temperature. It said it raised 45 degrees Celsius. It could have started at 0 degrees Celsius and went to 45 degrees Celsius, or it could have started at 20 degrees Celsius and went to 65 degrees Celsius. Let me write it down so you can see what I'm talking about. From 0 degrees Celsius to 45 degrees Celsius, that's a change of 45 degrees Celsius. Or it could have started at 20 degrees Celsius and it could have went to 65 degrees Celsius. That's also a change of 45 degrees Celsius. So they're telling me the temperature raised 45 degrees Celsius. I'm going to make my eraser bigger. I'll be here forever. Okay. Alright, so my mass is what I'm looking for. My change in temperature is 45 degrees Celsius. C. C is my specific heat. Did they give me specific heat anywhere in this problem? No. But they did tell me that we were talking about water. Now, why does the phone always ring when I'm trying to do these things? Okay. So we've got C, which is going to be right straight from our reference table, which is 4.18 joules per gram degree Celsius, or Kelvin. Okay, but since my temperature is in Celsius, see, degree Celsius here, I'm going to keep this as a degree Celsius. MC FBI break-in every 15 minutes. Junk calls. Okay. M, C, delta T. I lost my place because I'm worried about the break-ins now. Okay. And we have Q. 2,000 joules. And 2,000 joules is what we are adding to this sample of water. So now I have Q, I have M, I have C, and I have delta T. We're going to go over here and we're going to write our formulas. And then we're going to plug in all our numbers. 2,000 joules equals mass. My C is my specific heat, which is 4.18 joules per gram degree Celsius. And my change in temperature was 45 degrees Celsius. Okay, let's do the math. Get a pen. Q equals... Oh, I have Q. Sorry, I got sidetracked. Erase that. Erase that. Erase that. Okay. Alright, 2,000. We're going to divide both sides by 4.18 and 0.45. That's what I was going to do. I was going to get a different color pen. So we're going to divide both sides by 4.18. And I'm going to divide both sides by 45 degrees Celsius. And that will cancel these on this side of the equation. And I get 45 degrees Celsius here. This is joules per gram degree Celsius. And then I get X equals 10.6 grams. Joules will cancel, degrees Celsius will cancel, and I end up with grams. And I get 10.6 grams of H2O. Okay? Alright, last problem. And here I am back at a half-hour video on this stuff. I try to keep them short, but I keep talking. Okay, I need to scroll down. I need to erase this. Last problem. Now this problem is a little bit different than the ones that we did previously. In this problem, it says, what will be the final temperature of the water? Well, there's my question word, and that's what I was looking for when I skimmed through that problem. I said, what? And then find out what they're looking for. We're looking for the final temperature. They gave us joules, 520.0 joules, and they gave us mass, which is grams, and they gave us a temperature. Don't be fooled by that. That's why I put this on here, because this is my beaker, right? It's a lovely beaker. And in that beaker, I have 150 grams of water. and that water is at 30 degrees Celsius. We are going to be adding heat to that. How much heat? 520.0 joules. So what's going to happen to the temperature when I add heat to that? When you take a pot of water and you stick it on your stovetop, what happens to the temperature? It is going to go up. This is what we're going to be calculating. We're going to be calculating the change in temperature, and then we can calculate the final temperature of the water. Alright, let's get all our givens written down. So Q is joules, it's heat in joules, and that's going to be 520 joules. My mass of water is going to be 150 grams. We're going to have C, which is our specific heat. Where do we get that from? Table B, which is 4.18 joules per gram degree Celsius. And my change in temperature is what I am looking for. I'll make that X. Okay? Alright, write our formula down. Let me change colors so that it shows up better. Q equals MC delta T. I have 520 joules equals 150 grams times 4.18 joules per gram degree Celsius. Keep in mind I can use this specific heat because they're talking about water, and my change in temperature is what I am looking for. That's my X. Alright, so divide both sides by 150 and 4.18. I'll do that in blue. Divided by 150 and divided by 4.18. So these will cancel and these will cancel. But if I do it on the right side of my equation, I got to do it on the left. So I'm going to divide it by 150. I'm going to divide it by 4.18, leaving the units out just for simplicity. Because if my pen dies at this point in the video, I'm going to be very upset. Okay, so we got 520 divided by 150. 520 divided by 150 divided by 4.18. These two are multiplied by each other. You can multiply them out if you want. I don't find the need to do so. If you are going to put this in your calculator, make sure that you put the top number in your calculator first. 520 divided by 150, and then hit equals, and then hit divided by 4.18. When you do that, you're going to get 8.3 degrees Celsius. That's the change in temperature. That's not my answer. That's just giving me the change. The water started at 30 degrees. It's going to increase in temperature because I added heat to it. When I added heat, it went up 8.3 degrees. So I started at 30 degrees Celsius. I added 8.3 degrees Celsius, and I ended up at 38.3 degrees Celsius. That, my friends, is my final answer. If they had given you the question and it said 520 joules are removed from 150 grams of water at 30 degrees Celsius, what's the final temperature? Then my temperature would have went down by 8.3 degrees Celsius. Make sure you read your questions carefully. Okay, I hope this video helped. I know that it's again a half-hour video, but it seems to be my MO. If you have any questions, see me in class, and I'll see you in the next recording.